Quick word from our sponsor, Build Equinox. Equinox manufactures the CERV smart ventilation system in central Illinois at its 100% solar-powered facility. The CERV is the first ventilation system for residences with active monitoring and control of indoor air quality, measuring carbon dioxide, total volatile organic or compounds, VOCs, and with CERV's IAQ sensors, filtered fresh air is delivered to your client's home when they need it most. The CERV saves energy with sufficient heat pump energy exchange technology. Not only that, but this allows the CERV to actively heat or cool and dehumidify incoming fresh air. This makes the CERV ideal for any climate, hot, humid, or cold. CERV Ice connects the CERV online, making it even smarter. This enables online monitoring and control of CERV from any internet-connected device and provides information on the home's indoor air quality and impact on occupant health, cognition, and sleep. Don't just ventilate your client's home. Make sure their house is a healthy home with CERV Smart Ventilation. And a new report out, the Vermont report, you can check that out at the Build Equinox website, and it goes through about 13 passive house manufactured homes using the CERV, and it showcases their energy usage and comfort and also their health data of the homes as well, so make sure to check that out. And then real quick, Shrinergy is offering you or your clients emergency power backup, all-in-one inverter, lithium-ion batteries, and you can grab $300 off of that by the next day or two here using the coupon code GHI Solar Battery at shrinergy.com/solargenerators. Well, welcome everybody to Introduction to the Department of Energy's Building Energy Asset Scoring Tool. This course is approved for 1 hour in continuing education units, GBCI, AIA, AIBD, Certified Green Professional, BPI, NonWholeHouse, and NARI Green as well. And then, as I mentioned, American Institute of Architects, Health, Welfare, and Safety, and that may be applicable to your state-based design or contractor license. Today I'll be your moderator. My name is Brett Little, and I'm the executive director here at the nonprofit, the Green Home Institute. And for this session, we're going to be looking at specifically how to navigate the Department of Energy's Building Energy Asset Score with the ideal outcome to make informed and measured decisions for improved building performance. And today our speaker, Cliff is a former ship's captain with over 25 years in energy and facility management. He is the senior building performance engineer at Performance Systems Development. Cliff is involved with commercial energy auditing, energy modeling, program support, and training. He is a practicing energy auditor with multifamily specialty and has also worked as an engineering manager director in several large multifamily commercial buildings, including a 270-unit high-rise, 180-unit mixed-use building, and 25,000 square feet high-rise commercial building as well. Multifamily building analyst curriculum in 2010 was developed by Cliff, and he taught approximately 25 times and is currently licensed to 7 entities. The curriculum is currently licensed to 7 entities across the U.S. So with that, Cliff, I'd like to hand it off to you and take it away.
Showing today. Let me start sharing my screen here. Okay, hopefully everybody can see that first slide. I work for a company called Performance Systems Development, and we have been engaged by the Pacific Northwest Laboratories to help promote and support the Asset Score tool. As Brett already mentioned, he read my bio, so I can skip right over this. We'll start talking right away about the asset score. So it was developed by PNNL for the Department of Energy as a national standardized tool for assessing the physical and structural energy efficiency of commercial and multifamily residential buildings. It is dedicated to analyzing the structural and physical attributes, and I'll talk about that more later. But it's all about rating the asset itself and not how the building's being operated. It generates a simple energy efficiency rating that enables comparison among buildings and identifies opportunities to invest in energy efficiency upgrades. It's voluntary, it's 100% free, and it's available to everyone. Very simple score, 1 to 10, and it's based on that building, not a peer comparison like the portfolio manager. So it provides a targeted energy efficiency evaluation of the building's envelope and its major energy-related systems, lighting, hot water, HVAC. Again, it's all about the physical attributes of the particular building. And so how do they do that? What they've done is you'll enter information, and we're going to go ahead and create a model today. I'll take you right online and show you how to do it. It's quite simple. But to standardize all of the operating characteristics, so things like schedules and intensities and outside air, the things that the user, that the building operator has control over, have been standardized. So when you enter the information, you're entering it about the building's envelope, the mechanical systems, the lighting. You can't change the operating assumptions. And so that provides, that normalizes the analysis to the building itself, to the physical attributes of the building. So there's this big set of standardized assumptions, and this is an example of a community center on this slide. And this is the occupant density per square foot, right, 100. The equipment power density, watts per square foot, is 1.5. These are things that will vary from building to building, but they've been standardized here so that those variances don't affect the score. So the same thing, there's a whole list, and I'll go into a little more detail of these assumptions. The assumptions are based on a few things. They're based on the use type, they're based on the date the building was built, and they're based on the location of the building by zip code. So these are some of the assumptions: lighting, occupancy, cooling set points, etc. And this is where you can go to find this. And I'm going to take you there in just a minute. In fact, we can go ahead and do that now. Let's get to, so Building Energy Asset Score is an online tool. If you Google it, here's what you get right at the top here. This is the DOE's Energy Efficiency and Renewable Energy website, and it's an informational website. And it's got a blurb here, some informational stuff about the asset score. And if you go down to the bottom, it says use the asset score. That'll take you right to the asset score page. And so you're going to have to create an account to use it. I already have one, obviously. But it gives you the opportunity to register right here. So first thing I'd like to talk about is help. So if you need any help, there's a lot of help resources here. There's a user's guide, and there's a forum, and then there's a long list of resources, and then there's the help desk. Clicking this, and you can also do that by clicking on this button here, but this will just go ahead and bring you to the help desk where you can create a new ticket. This is my help desk, so it's going to be different than yours because I'm the administrator. I am the help desk. So if anybody wants access to me or have questions about asset score anytime, that's the way to do it. Just go ahead and click on this, or go through this link here, and it'll take you right to the help desk team of which I'm a member. And if it's most of the questions I will field, when it gets down into the nitty-gritty of the development, we have developers who will answer the questions if you have a model that fails. So one thing I wanted to point out is these resources here. Again, this is a 1-hour webinar, so I can't dig too deeply. So if you wanted to get a little deeper into it, you could go ahead and go to this page, and it's got all kinds of great stuff. And one of the things I wanted to show, these data collection forms, for those of you who do energy audits of any kind, an asset score, it has got a lot of great features built into it, in that you don't need a lot of information to use the tool. But if you have it, you can go ahead and change the defaults. The defaults are very powerful, but this is a great tool for any type of energy audit. This is my standard. When I go out and do an ASHRAE level 2, I bring this with me with slight modification. This is asking all the right questions for an energy auditor in the field. So, you know, it's got some good descriptions too on how to describe spaces and geometry in terms of an energy model. So this is a nice little resource here. I'm going to go ahead and download this. I'm going to use it later. And so to go back to the resource page, let's see. It also has this right here. So if you're in the field, you want to build an asset score model, it's got this data collection priority map. And this tells you which are the most important things. These ones that are highlighted in dark green will have the highest impact on the model, and it's by use type and climate zone. So if you know you're in 5B, which I think is Pacific Northwest, I could be wrong, then the lighting has the highest impact on the model. The wall insulation and window U values, envelope characteristics are next in line, and then geometry and fan, etc. So this will help you, you know, as you do an audit. What's the most important stuff? Again, asset score is filled with very relevant defaults. If you don't know what the wall insulation is, the default values in asset score are statistically based on the date the building was built and that region. So you have this tool here to kind of help you what's the most important information. So I'm going to go back to the presentation. Oh, real quickly, one more. We talked about how there's a lot of assumptions for operating, not assumptions, standardized assumptions for the operating characteristics. And so those are contained here in this operation. If you ever wanted to know, well, what are the operating assumptions? Occupancy schedule hours per week for each of the use types are right here. Occupancy density per square foot. These are the assumptions in case you wanted to know. And again, this is the one, this what makes asset score a little different than a lot of the other tools you use, because you have no control over these. These are what they are. Now, once you build the model, what happens under the hood in asset score is it's creating an energy model using Energy Plus. And Energy Plus is an extremely powerful energy modeling tool that was developed by the Department of Energy. And most of the software tools you buy out there that do energy modeling have Energy Plus under the hood. All the big commercial, you know, Train Trace and the Carrier HAP design, they all use Energy Plus under the hood. And it's a very complicated tool. To model an Energy Plus requires a high level of engineering skill. So the DOE developed a platform called Open Studio, which is an interface. It also sits on top of Energy Plus. And Asset Score generates an Open Studio model. So at the end of your modeling, if you wanted to export a model into Open Studio and then change those assumptions, it's a capability that the tool has. So I'm going to go back to the presentation quickly. Let's see. There we go. So the objective when they built the tool was to expand the awareness of opportunities to invest in building energy upgrades. And one of the great things about Asset Score is it's going to make some recommendations for you. Again, you can crank out one of these models in about an hour or two, and it's going to give you not just a score, but it's going to give you some recommendations. It's going to say you need a lighting upgrade, maybe you need a window upgrade, maybe you want to do some control upgrades to your air handlers. Again, they're not rigorously modeled. It won't give you net present value or payback or SIR or any of that. You have to dig in a little deeper. But it's a great tool for screening and saying, okay, this building does have potential for capital upgrades. These are the capital upgrades to investigate further. So I just recently did a survey with a lot of the users and found one of the most common, if not the most common use case is for people to screen buildings. And especially if there's a lot of buildings in your portfolio, you can screen hundreds of them in very little time. So it's not intended as a replacement for the benchmarking tool or an energy audit. It's intended to complement these things. In fact, it works remarkably well coupled with Portfolio Manager. So these are the use types, right? Remember, everything is based, all these assumptions are based on the use types, and these are them. And the bottom one I find to be the most powerful. You can do any of these use types: office, retail, post office, senior center, and any building with a mixed use of the above types. And that's a very powerful tool. So who can use Asset Score? Absolutely anybody. It's free. It's public domain. Log in. Go ahead and use it. Who is intended for? Stakeholders, building owners, third-party property and facility managers, energy service companies and consultants, engineers, utility program administrators, architects, engineers, and state and local governors. And again, I just did a large survey, and those are the people that are using it. Primarily third-party consultants. And we've identified a couple of different use cases that are the most common, and it's really used predominantly as a screening tool or as a starting point for more serious study. So how does it work? You get this score. The scale is a 10-point scale to evaluate the energy efficiency of the physical characteristics and the energy-related systems. It's a point value, and it's based on the building's predicted source energy use from the energy model. So you will create this model. The model is a full energy plus simulation that will happen, and that will predict the energy use. It's standardized all of the operating assumptions, so you're going to get this score based that is rating the building's physical attributes. They're rounded to the nearest half point, and a score of 10 represents the lowest expected energy use for a building of that use type using the current building energy efficiency technologies. And again, that scale was created based on huge databases of buildings, the CEUS and various others. They ran thousands of these models within these different climate zones for these different types of buildings and developed this range of EUI. Not every building is on the same scale. An office building will have a different scale based on the range of EUIs for office buildings. EUI is energy use intensity. That's energy per unit square foot. So that'd be thousands of BTUs per square foot or watts per square foot. And so this ensures that the different building types are scored fairly by accounting for differences in standard operating conditions. Again, a hospital is going to have different operating conditions than an office building. It's going to be occupant density will be higher, lighting density will be higher, the occupancy schedule is 24/7. So it accounts for that by this shifting scale. So a lot of you are probably familiar with Portfolio Manager. That is a tool administered by the EPA. That tool, you enter utility data and some of the building characteristics, but mostly this is regressing the utility data and scoring, generating an EUI based on the use type and the actual data, and then comparing it to peer buildings. So it doesn't really take into account, a building can have a good Portfolio Manager score with really bad equipment. You can have old lights and old boilers and old chillers. If you have a crew operating that building that it's got occupancy sensors and is turning lights off that isn't needed and harvesting daylight, and then the boiler might be old, but it's lovingly maintained and everything's on a reset schedule. So you can get a good PM score and have an old building. And that's where energy score, asset score comes in, because all those things that the operator can do to increase the PM score, to lower the energy use, are not accounted for. Their standard assumptions will nullify those in the score, and so they'll tell you, is the boiler old? Are the lighting systems old? So when you compare these two metrics, and we call this a quadrant analysis, we developed this here at PSD, and this will something we're trying to get out to the public right now. But this you put the PM score on the bottom and the asset score on the top. And the limiting thing is here is use types, because there are some things you can get a PM score for that you can't get. I mean, the use types aren't all the same, so you can't necessarily get a PM score for all the buildings that you can develop an asset score for. But in the ones that you can see here that you can have a very high portfolio manager score, but have a low asset score. And by the same token, you can have a very good asset score and have a low PM score. And this is state-of-the-art LED lights that are left on all day. So this here, where you have both of them are good, this is the head of the class. You know, you can see this dual score kind of puts you, oops, what happened? You know, into one of these quadrants, and these quadrants can tell you, okay, so I've got a good PM score but a low asset score. This quadrant tells you that this building is a candidate for capital improvements. This one up here tells you that the building, you know, it's got a great asset score, it's got good equipment, but it's getting a bad score. This needs operational improvements. This needs to be retro-commissioned or retuned, or an examination of the O&M characteristics of, you know, the operating parameters. So again, these two tools are both great in and of themselves, but you put them together and it's just powerful. And again, I said this is the most common use case, people taking both of these scores, putting them together against a portfolio of buildings, or even just one building. Maybe you're a small portfolio, you got 2 or 3 buildings. Well, which one do I spend my money on, and how do I spend my money? Should I retune this building? No, this building doesn't need any tuning. It's operating magnificently even with bad equipment. So again, great way to just spend 2 or 3 hours on a building and get a really good feel for what needs to be done. Okay, excuse me a second. I'm going to, let's see here. So we're going to look at a couple of, there's 2 modes in asset score. You can do a preview and you can do a full asset score. And so the preview is a lot of defaults, very little, it's presumed that you don't know much about the building. And so there's a lot of standardized defaults. You know, it's really creating a model based on use type and date built and zip code. You can make changes to things, again, if you do have information about the building, but with preview mode, it's fast, it's easy, and you could do 100 buildings in a day or 2. We're going to look at the full asset score. If you can do a full one, you can do a preview mode, and the full mode is a touch more powerful. So again, we're talking about planning it out. You're going to have to create geometry, and I'm going to be going kind of fast because I don't have as much time as I usually have. But if this is your floor plan, first floor, second floor, you're going to create these zones, this geometry. Again, you grab your data collection form. Maybe you did an audit, maybe you didn't. I use, like I said, various spreadsheets in addition to these tools. These are the things these are some of the information you might need. So we're just going to actually jump into it. Let me go to the site here. So when you register, you're going to get a home screen like this. And these are some of the buildings I've modeled. I do a lot of training, so I do a lot of these test buildings. But these are actual buildings that we modeled for clients. Again, you can do very simple models like these, and you can do complicated models. And these ones, these complicated ones, the asset score is meant to be a screening tool. You start getting into these complex geometries, and it may make sense to upgrade to a different tool. But it's certainly capable of modeling complex geometries and complex buildings. It does have some limitations we'll talk. So we'll talk about as we go. So you go up here to the right, new building, and I'm going to have to be quick here. Test. And here's, again, very important, required field. Total floor area. I say 7,500 square. This is our address here at PSD, Scenic Ithaca, New York. You have to do this for every building. Again, some of these information is going to be used to create these defaults. So it's important to get that stuff in there. And then there's two phases of input mode. Like I said, we're going to go with the full report. The first input phase is you're sort of creating some systems. Oh, what happened? There we go. You're going to create these things to use in your model as you go. So we're going to create two use types. Add use type. Just to demonstrate that you can have two. We're going to have office and community center in the same building. And just click next. And then you're going to start building surfaces. We're just going to stick with one. So here, we'll stick with a built-up metal deck, built-up roof on a metal deck. And what about thermal properties? We can do U value, insulation thickness, or R value, but we can click I don't know, and it's going to take that zip code to figure out what climate zone we're in, look at the year, and based on statistically what the common roofs for that use type were in that region, it's going to generate a default value. So for walls, we'll go ahead do the same thing. We're going to keep this simple. So this is siding on a wood frame. This is a, we'll just say this is an R12 wall. That's pretty common. Windows, we're going to go with wood vinyl. Single pane, let's give ourselves an upgrade. And the glass floor, there's no fill type, so it doesn't matter, none. Now you can import U values, solar heat gain coefficient, and visual transmittance if you know them. And if you don't, it's going to base the properties of the windows on the other inputs. But if you have specific data, you can put it in there and it will affect the model. And for floors, we're going to put in slab on grade with no insulation. And then we'll go ahead and add a wood framed, but we don't know what that, it's going to let that choose for us. So then we hit next, and we're going to select our lighting system. And it's a surface mount, let's call it a T12. And what are those 8-footers? 96, I believe. 2 lamps per fixture. This is some old lights, right? Now, HVAC. HVAC, you're limited in that they've chosen the most common HVAC systems, and the tool is going to auto-size them. It's going to build them out, but you can, when you talk about Energy Plus and Open Studio and Train Trace, you can get very complex. You can design a system from the ground up. That adds a level of complexity. Again, this tool is meant to be streamlined and simple. So it gives you a choice. Now, you can build it from the ground up. You can add boiler loops, heating loop, cooling loop, condenser loops. You can add the air handlers in the specific equipment, or you can go ahead and take these package systems that they offer for you. So we're going to go ahead with a VAV, hot water reheat. It's a very common system in commercial buildings. So when we picked that system, it went ahead and built this equipment here. Equipment type air handler, distribution, multiple zone, cooling source, chiller. And if you look at this tool I downloaded, this data, this is the long form data collection tool that I showed you earlier, data collection form. These are the types of systems that are in that drop down I just selected, and this is the equipment that it will build automatically. So that's, again, a little time saver there. You can go ahead and create this whole system, and you don't have to, because otherwise you'd have to build those loops yourself, etc. So we built that. Let's add one piece of zone equipment. Let's just say we got some packaged terminal heat pumps in the building as well. Again, those are the cooling source is terminal DX. So some of this information is just for documentation. You can add pieces of equipment and output capacity, but asset score is going to auto-size that. And so those won't affect the model. The model is going to have the capacity that asset score assigns to it. However, you can input COP, and that will affect the model. If you know the coefficient of performance of kW per ton and you convert to COP, you can stick that in there, and the model will use that for efficiency. So again, some of the information that you can enter affects the model, some of it doesn't. Again, the default fields are filled out, so you don't have to add anything. So this is the last, no, actually this isn't. So you're going to have one quick water heater. We're going to use a electric distributed, right? So these are little water heaters right at the bathroom. That's very common in commercial buildings. We don't know anything about it. Let's just let asset score will assign that. And again, normally I'd try to go into more detail. We've got, like I said, we're limited for time. So operations. This will not affect the model. Any operations that you add, elevators or schedules, will not affect the model. They're just for you to document. If you know these things about the building, this gets it into the asset score report. But this will have no effect. Again, all operational considerations are standardized, so it won't make an effect. So now we go into the data input screens. And of course, that's going to take a moment. Okay, so again, you can't go back to this type of mode, but anything you did here, you can do in the next mode anyway. So again, here's your input. We're in the geometry part, so every building, see these little warning symbols mean that you can't proceed to the next tab until the requirements for this entry have been made. So every building has to have at least one block. So I clicked create a new block. I don't know if you saw that. Create a new block, add a little plus symbol there, and start talking about it. And we'll call it block one floor, floor to floor height, floor to ceiling height. Now, if you notice here, if these numbers are not the same, then asset score is going to create a plenum. And asset score is not going to let you make the floor to ceiling height greater than the floor to floor height. So it's not going to let you mess that up. Generally, there's a plenum in buildings like this. That's where the return air happens. And these are strong. This is the building's volume. This is one of the powerful levers in the model. This has a big effect on the model. So if you want the building, you can orient the building in space with this block. This is going to be facing true north. And then you have some standard geometries that you can use. We're going to keep it simple here. Just make this block squarish. And bingo, you've got yourself your first bit of geometry. You can zoom in, move it around. You hold the left mouse down and tool it around. You can change your orientations here. Show the top, show the bottom, click to the north face, etc. So I'm going to add another block real quick. We're going to make this one much the same, except it's going to be smaller and narrow. So this is 25, runs the length of the building one way. Say 70. Oops, something went wrong there. That did not meant for that to happen. Let's see here. Or I can just edit it, right? I can hit this little pencil and edit the block. And what did I do wrong? I made it 770 instead of 70. There, fixes it. So you're not stuck with where they put it. You can pick that up and move it around, put it any place you like. It's got a snap to functionality. So no more little warning symbol here. I can move on to the next. The next is use type, and every block has to have a use type. And here, just drag and drop functionality. Simple, right? You have this light blue is community center. This block has been assigned to that. It takes that color. This is an office use. So now both blocks have a use type. The little warning is gone. I can move over to the surfaces. So again, drag and drop functionality. Just put every block has to have a roof, right? You can, let's just go to the next here. Now each of these blocks has a use assigned to it, a roof. Same thing with walls. We'll go ahead and create the walls. And windows. So for windows, need a little bit more. You created the geometry, so it knows how big the walls are. You didn't have to enter much. So what kind of layout do we have? So continuous is going to model the windows as a fraction of the wall surface. So you create a window to wall ratio, 20% say, and when the model gets created, if you do it this way, which is a simple way to do it if you don't have measurements for the windows, then it's going to create it as, a strip of window along the top of the wall. If you wanted to model the discrete windows and you had the measurements, you can do that. You don't have time for that. Not every block has to have windows. Did I do both blocks? I didn't, so 0.2. And then, of course, they all have to have a floor. Slab on grade would be the bottom block, and then the wood frame. And again, you've already defined that surface, so there's nothing else to do there. And up top, you're going to have that wood framed floor. And all our warning flag is gone. So now we're going to assign lighting. So you did an audit, you have total fixtures, you can go ahead and count and add fixtures. If you have occupancy controls, you can click that. Or you can keep it simple and do use percent. So the whole building, 100% of this building is served by those T12s, or 100% of that block is served by those T12s. And asset score will auto-size that system. It has the standardized, not standardized, but statistically most common lighting densities for buildings of that epoch in that location. And so now lighting's gone, and now HVAC. Now every single block has to have HVAC. Now if this building had 10 zones and 10 HVAC systems, you would have to either model it as 10 blocks or aggregate those systems. Again, from an energy model standpoint, if you have, like in an apartment building, every apartment has a 50,000 BTU furnace and they're pretty much all the same. From an energy model standpoint, 50,000 BTU per hour furnaces that are 85% efficient is exactly the same as one 500,000 BTU per hour of the same efficiency. So you can aggregate HVAC equipment. If you have different equipment and different efficiencies, you can do what's called a weighted average. And we don't have time to talk about that. That's our advanced training. But we kept this building simple. So this is, remember the loops. The loops are not assigned to a lot. These are assigned to the whole building, and you can't drag and drop these. But you want to know, does the chiller plant loop serve the, excuse me, you got a condenser loop, a chiller loop, a boiler loop. They're building wide. But the distribution equipment, right, air handlers can be assigned to a block. Every block needs to have an HVAC system. What kind of thermal zone layout? Perimeter and core is normal, so we'll go ahead and give it that. Excuse me. Perimeter don't. We'll talk about that a little bit more if we have time. And then let's presume that the top was a zone equipment. Maybe it was an addition later. The loops don't go into the upper building. You have these packaged heat pumps up there. So again, this one, we're going to keep that as a single zone. So there you have, this is your hot water. Buildings don't require hot water systems, so there's no flag there. We're going to go ahead and give it one. And again, you see these little radio check boxes. And you can assign low flow faucets. You get certain attributes that you can just click on and off. And again, here's operations. And as I mentioned, operations don't affect the model, so I didn't dive into it. And then here's your summary. All right, so once you get to this little eye here, this is everything you did. This is your block one, your geometry, your square footage, use type, floors. What if you look at this and say, oh gosh, I made a mistake. The floor-to-floor ceiling height was 15. You click that little pencil and it lets you edit it again. So, you know, this is sort of the last place I go and review all my information. And if anything needs to change, this is one place to do it. You can also go back to the tabs and make changes. So we look at this building and we see that we have entered all the information, and we can go ahead and score the building. And so we're going to do that. It's going to give us this little warning. Simulating this building could take upwards of an hour, depending on server load. So it's going to go back to my buildings. That's this home button here. It's going to take us a second. But now that we're back in my buildings here it is, shows that it's scoring. And I'll get an email when that scores. I built that same building yesterday. And so this is what it looks like when you get the report. After it scores, you get this report. And it says, this is your current score, and this is the potential score if you make some upgrades. So the building scores 7, which the building I built had better windows yesterday and had a few things a little bit better. That's why the one I'm scoring now will probably score less. But it also says you could get up to a 9 by making some upgrades. So this report shows, this is a building summary right here. This is the score. And then it kind of delves into, regurgitates. This is the report, right? So it has all the information, the inputs, right? A good energy model report will list the inputs so that it's transparent and can be replicated. It does it for each block, right? So there's the score. Now you can download, this is the summary of the report. You can actually download the report itself, which has a little bit more detail to it, right? And it goes into over here, source and site energy. So it tells you these characteristics about the building. And this is the estimated source energy, the energy use intensity in thousands of BTUs per square foot in the upgraded building and in the base building. And then this just kind of tells you the energy use by end use over here. And then it does it on a block by block basis. It scores each block and then reports on each block. And when you get to this part here, sorry I'm scrolling around so much. This is ranking. So your interior lighting is good. Your cooling is fair. Your overall HVA. This is just sort of telling you qualitatively about your building. Your roof envelope is fair. Your walls are good. Again, this is source energy by end use, right? So this line is where the site energy versus source energy line is drawn. So remember, for every kilowatt you use at the plug, they have to generate 3 kilowatts to make that happen. So a lot of the energy in the fuel goes up the smokestack and is lost in transmission. So this is just sort of demonstrating that visually. And then this is the characteristics of the block itself. Each block, 1 and 2. And, you know, it tells you these things, whether you estimated it or put a value in there. So let's see, get back to the top here. I think I missed an important part. Where are those recommendations? Effective upgrade opportunities. Add roof insulation. Now, again, you didn't model the cost and you didn't model the operational characteristics, so it can't tell you precisely how much energy you're going to save. It just says your energy savings will be high, medium, or low. And as far as cost, it just uses this very basic and intuitive, this is a low cost, this is a high cost. So again, this is intended to drive you towards more further study. If this whole building didn't have any high impact retrofits, then you can say, I don't need to spend any more time or effort. But this building's got some potential. You can get some low cost, high impact, low and medium cost, high impact savings from this building. So again, let me go back to the presentation. Let's see. That's not it. There we go. So again, this is just going over the report. I just did that. So one of the things you can do, again, let's just say you wanted, you said, okay, I want to take this to the next level. I want to model my operational assumptions. I want to put schedules in there and, you know, occupant density and lighting densities that are different than the assumptions. You can export this to a tool called OpenStudio, and OpenStudio is part of a family of tools that the DOE has developed, and it's this platform for energy plus energy modeling. Extremely powerful platform. It's another one, perfectly free. Everybody can use it. It's open source. People are building on this all the time. When you create a model in OpenStudio, the way you manipulate that model is with a small script called a measure, and there's a library of these scripts that people have access to. So the way to do that, and again, I'm going to have to cut this a little bit short. Let's see here. Go back to the little toolbars in the way. There we go. You can download this model, and it downloads. I'm not going to be able to open the model for you, but there's this OpenStudio model. What the heck? I think I have a second to open it. So now if you wanted to go in and modify this model, you can. Now, you're going to have to assign a weather file specific to this model, but here's, you know, this is OpenStudio. This is your schedules, your geometry, your plug loads, all these things that you can go right into the fine details and build wall structures from the ground up. So here's your here's the model we built, the geometry. Remember I showed you how the windows get assigned. We could have assigned these discretely. So again, that's just the enhanced functionality. That's just wanted to demonstrate that. We don't have time to talk about it too much. So let's go back real quickly, finish off the presentation. Another thing that you can do is you can connect your Energy Star Portfolio Manager account and share it with Asset Score. And again, you can import buildings into Asset Score, and it's not a lot of data. It's basically the building name, the use type, a few of the high-level characteristics of the building, but it would save on data entry if you're doing both. And we don't have time to go into the step-by-step for that. So talked about this. If you ever need help, you click that little button right there, Help Desk, and that'll take you, that'll end in my inbox, and I will respond within hours. So that's the presentation. I wanted to leave a little time for questions. If anybody has questions, I don't know if Brett, you're going to take back over, or there we go.
Yeah, hey everybody. We definitely got time for questions. Start putting your questions in, and as you're putting those questions in, I just want to real quick thank all of you for joining us. Thank our members, thank our volunteers, our board of directors. Big thanks to our sponsors, GeoComfort, Geothermal Systems, Build Equinox, CERV, Niagara Conservation, Panasonic Ventilation, Certainty Air Renew, and then make sure to check out Shrinergy for small and large solar PV and microgrid solutions. For those of you looking to get your CEUs, make sure to take the survey that comes either through email or pops up at the end. For those of you watching this in the future on demand, make sure to take the 10-question quiz with an 80% passing rate. So yeah, let's give some time for some questions here. I do definitely have a couple myself to jumpstart this, and I think maybe one of the biggest ones in everybody's mind is that are there any incentives, you know, whether they be tax-based or utility-based, that could be tied to using this tool or, you know, achieving a certain score?
So utility programs there right now are just starting to adopt it because the tool isn't that old, and utilities tend to move very slowly. And so there's a lot of effort right now to credential the score to make it useful to utilities. And it's connected right now. There's a lot of cities throughout the country that are putting out mandates for benchmarking and rating a building, and also several that have disclosure laws for real estate transactions. And asset score is being implemented, for example, the New York City benchmarking. And it's not the asset score itself, it's something called the reporting template. So there is a functionality in asset score for data collection where you can enter a lot of building data into this tool, the asset score audit template. And this is compliant with a lot of these disclosure mandates, a lot of these benchmark mandates. I'm not aware yet of any utility programs that are using it, but I know of at least a half dozen that are considering it and that it's been proposed. Actually, there is one that's using it in California, in Southern California, something called the Energy Collaborative, SoCal Gas, etc., are using asset score in their incentive program. So again, it really varies from state to state and utility area to utility area, but you can certainly count on seeing it adopted more. It's a very useful tool, and the simplicity of it makes it very attractive to the utilities, because energy modeling is one of the difficult things that they have to deal with.
Great. For those who are home performance, or not home performance, but rather building contractors who are doing upgrades for folks, and maybe they're the ones doing the audit and making recommendations, is there the ability for them to both go in and manipulate the recommendations on the output side, either as far as trying to get a better score or just what they recommend the building owners do?
So once you score the building, you can't edit it anymore, except you have to take it out into Open Studio. And those recommendations are generated by an engine, and there is no way to change them except to change the parameters of the building. So if you want to generate an insulation recommendation, you have to lower the value, put in a bad wall, model a bad wall, and the engine will catch that and tell you to to improve that wall. But you can't manually enter a recommendation into the asset score tool. Now, if you want to, you can export to Open Studio, and that's what Open Studio is all about. But that engine is put there to help people develop what should I be considering, and so you can't manipulate it, unfortunately.
So I guess for those who might be attempting to achieve a certain score, or maybe hit a 10 or whatever, would the only way to do it is to go back and remodel the building as if it was the way they wanted it and see if it comes in at that high level? Is that essentially the only way to do that?
I mean, you could do it that way. It generates a potential score in addition to the actual score. Mm-hmm. So that already happens when you score the building. It tells you what the potential improvement is. Scoring a 10 might be difficult, but you can certainly go in there. It'll tell you if you do these improvements. Remember, it showed the score twice. It showed the current building of 7 and the potential of 9. But you could model the building twice. One is a base building and one is a improved building to see how that affects the score. You certainly could.
What was my other question here? On that note, is there any quality assurance as far as ensuring models are done right or scores are being done correctly, or is that something another entity would have to build in on their own?
No, you'd have to build that in on your own, but that's what, like I said, that report has the inputs, and it defines the assumptions and the estimates. So that report was designed to be QA friendly. Like I said, most QA programs, that's to say the standard energy model report lists the inputs and the outputs and documents the assumptions, and the report does that. But and I wouldn't say it's for lack of a better word, idiot-proof, but it's as close to you can get to that as possible, because if you don't have information, the defaults are all defendable. They're all based on statistical data. So it's very robust in that it does not, it's hard to screw up the model. Really, you have to work, you have to actually enter something incorrectly. If you just go with the defaults, it's going to give you a defensible, fairly accurate state of the building.
Got it. For those buildings that are looking, or that have solar energy, can that be taken into account in this?
No, it does not model renewables.
Now I remember the other question. So for architects and designers who are, involved in building a new building, is this something that they could use to design a theoretical building and then have that give them recommendations on how to improve it, or can it only be for existing buildings?
You could do a theoretical building. I don't know that that's the best use case. When you talk about building an energy model to inform design, those tend to be more complex models, and you want more ability to manipulate the parameters. So you could do it, especially if you are early in the design phase and you wanted to get some quick information without, if there's a lead model or an Open Studio or Energy Plus model, that's hundreds of hours to create it. But if you wanted to real quickly use it as a screening tool, say, what if I build it this way and I build it that way? What's the potential? But it's not the intended use of it. It is not a design. It wasn't designed to be to inform building design. It was designed to rate existing buildings as its primary use.
In that one photo, you showed a graph where kind of on the right side was EPA 0 to 100, and then on the left side was DOE asset 0 to 10. Is that something you created, or is that one of those extra outputs if you can sync both your portfolio manager and your DOE?
No, we created that at PSD, and we're trying to get that out to the public through PNNL. We're writing a proposal now to offer it. Again, there's some difficulties because not all buildings, the difficulty is if you don't have a PM score, it doesn't work, right? Not all buildings can get scored, but it is something that we have right now. It's not something that's available to the public just yet. You could scratch one out yourself on a spreadsheet. That's how we started, and then just saw, this is powerful, and then we have a graphics person in house that made it pretty, but really that started out as an Excel spreadsheet, and that scatter plot you saw in there, those were all actual buildings that we had scored in both, and we just saw what a great tool it was. Made the slides, and now we're trying to get PNNL to adopt it, and they seem to be quite interested in that, so it's something to keep your eyes open for.
Yeah, it definitely seems very helpful. So do you know any, I know a lot of green building programs sort of pitch themselves to an energy baseline program. Do you know of any green certifications, local or regional or national, that have said, we'll accept the DOE building asset score as a pathway for your energy credits?
And so again, compliance, they're at the level where they're getting compliance with these city mandate programs, but that's the kind of thing that will lead to, the next level, I think, is attaching it to incentives. And again, it just hasn't been around long enough. These green building programs are a little more responsive than utilities, but it's the same thing. They're not rapid adopters. It doesn't make sense to build these complex certification programs. They want to see QA. They want the savings and the scores credentialed, and that's what's in the process now. They're trying to make these scores, they're trying to credential them so that they're transparent and replicable and standardized to the point where these entities will feel comfortable using them.
Yeah, I will say our Green Star tool that we have, which is a lot more willing to adopt or be rapid to increasing its use of things. We have adopted the DOE Home Energy Score, and And so starting at a 5 if you're doing a remodel. And so we've actually decided to adopt the asset score on the multifamily or mixed use side. So any building who wants to pursue Green Star, would be looking at achieving at least a 5 on that DOE asset score, and then you can score the rest of your points from there on the renovation side. So that's just more of a statement that we've decided to adopt it, and so anybody who's looking into that, who's listening into this, can use it.
Well, that's great to know. And I'm sure PNNL will be happy if they don't already know that they're getting picked up and used. That's what they want. If they want to see this thing adopted, like I said, they built a better mousetrap, and they just want to start catching mice with it.
Mm-hmm. Yeah. Well, hey, Clifford, it's 1 o'clock. I don't see any more questions. Really want to thank you for your time, and for DOE and Engineering Performance Systems for having you out. So just real quick, where can people go to find more information if they're looking to start using the tool?
BuildingEnergyAssetScore.com. BuildingEnergyScore.energy.gov. That website I took you to. Just Google, Building Energy Asset Score, and come to that page. Hit the help desk or the help drop-down menu. There's that resources for self-study, and there's the help desk for direct questions.
Okay, great. Well, thank you, and take care. Have a great week, everybody.
Thank you, Brett. Thank you, everybody.